Modifying an Azure Resource Manager (ARM) template involves thoughtful adjustments to predefined JSON files that describe Azure resources. These templates define parameters, variables, and resource configurations, providing a layer of procedural clarity to deployments. In the context of Azure Compute Resources, template modifications facilitate updates to virtual machines, storage accounts, and related components without restructuring entire environments. Building on prior knowledge of ARM template syntax, this slide explores how developers can identify sections of the template that require changes, address version control for each modification, and maintain readability. The goal is to ensure reliable deployments by adjusting and enhancing existing templates to reflect evolving infrastructure needs. Before performing detailed modifications, it is crucial to revisit the essential sections of an ARM template. The template generally comprises parameters, variables, resources, outputs, and sometimes functions. Parameters allow for reusable input values, while variables help organize repeated expressions. Resources are the main building blocks, each describing a particular Azure service or configuration. Outputs offer readability by returning helpful information post-deployment. Having this structural overview helps pinpoint where changes might be necessary. When adjusting an existing template, one must locate the relevant sections for updates, analyze dependencies among resources, and ascertain that parameter or variable modifications align with organizational standards. Modifying parameter and variable sections offers flexibility when adapting a template to new requirements. For instance, altering default values for capacity-related parameters can ensure that newly provisioned virtual machines reflect shifting workload demands. It is also possible to introduce additional parameters for dynamic resource configuration, which prevents the need for multiple template versions. Changes to variables may include updating resource naming conventions or referencing newly introduced resources. These modifications should be planned with clarity in mind, ensuring that parameter descriptions are aligned with the resource usage. Through prudent updates, template maintainers preserve readability and enhance maintainability over time. Resource configuration changes are central to extending or refining existing ARM templates. Modifications may range from adding specific properties to an existing virtual machine resource to altering how load balancers handle traffic. For example, specifying different operating system settings or storage types can refine the performance of a virtual machine. When making these edits, it is vital to maintain consistent naming conventions and keep resource dependencies intact. Updating resource configurations often requires referencing parameter or variable changes to ensure cohesive adjustments. Maintaining strict versioning practices can help teams track these updates, preventing confusion regarding which template iteration reflects current infrastructure. Conditions and loops provide advanced capabilities within ARM templates, assisting in orchestrating complex deployment scenarios. Conditions use simple expressions to control the creation of resources based on parameter values, enabling more flexible design. Loops allow repeated resource creation without duplicating code, especially useful when multiple instances of the same type of resource must be deployed. Introducing these constructs can streamline large-scale deployments for Azure Compute services like clusters of virtual machines. When adding conditions or loops, it is best practice to carefully document them in the template and test with different parameter values to confirm reliable, repeatable results across environments. ARM templates rely on a robust dependency model to control resource creation order. When modifying an existing template, it is crucial to ensure updated or newly added resources maintain correct dependency chains. For example, a virtual machine resource might depend on a network interface, which in turn depends on a virtual network. Adjusting or inserting resources without updating the depends on property may lead to deployment errors or partial configurations. Consistency in referencing resource names and types promotes clarity. Properly managing dependencies ensures that each resource is provisioned only after all prerequisites are in place, thus minimizing deployment failures and configuration issues. After making revisions, it is essential to test and validate the updated template to avoid unexpected faults. Tools like Azure CLI and PowerShell enable local template validation, offering immediate feedback on syntax and structural errors. The test deployment can be executed in a non-production environment or using Azure Dev/Test subscriptions to verify the provisioning sequence. Validation should consider parameter boundary values to ensure each scenario behaves as anticipated. By reviewing deployment logs, one can detect misconfigurations such as incorrect resource IDs or missing values. Conducting thorough tests reduces the likelihood of interruptions and maximizes the reliability of ARM template modifications. A variety of tools support efficient template modification. Visual Studio Code with the Azure Resource Manager tools extension highlights syntax and schema issues, enabling quick discovery of errors. Azure CLI's deployment commands facilitate iterative testing, while GitHub Actions or Azure DevOps pipelines integrate continuous integration for each template update. Best practices include adhering to consistent naming patterns, limiting parameter usage to essential fields, and incorporating secure references for sensitive data like passwords or secrets. Additional guidelines suggest thorough version control, tagging resources for discoverability, and embedding descriptive comments. Combining these practices fosters streamlined collaboration and reproducible modifications across teams. Incorporating template modifications into continuous integration and continuous deployment (CI/CD) processes allows automated validation and consistent deployments. Developers can link repositories containing ARM templates to Azure DevOps pipelines or GitHub Actions, which automatically run validation checks whenever changes are pushed. The pipeline can deploy updates to testing environments, ensuring that each code iteration is verified before production release. Such an approach minimizes human error and creates traceable records of every modification. By integrating robust checks, including pre- and post-deployment validation, teams ensure that template changes remain stable and aligned with organizational governance, promoting a more efficient DevOps culture. Common pitfalls in modifying ARM templates include omitting dependencies, neglecting parameter constraints, or misusing variables, leading to unpredictable deployments. Failing to maintain consistent resource naming or ignoring recommended schema versions can also complicate debugging. Another frequent oversight is not updating references in the depends on property, triggering incomplete resource deployments. Security aspects, such as hard-coded credentials or insufficient access control, can introduce significant vulnerabilities. Following recommended schema guidelines, verifying version compatibility, and applying security best practices mitigate these risks. Regular reviews of deployed configurations and alignment with organizational standards further ensure that template modifications stand up to evolving infrastructure needs.